Okay guys, what we're going to look at today is graphing linear equations. Alright, now in this case the linear equations will be in the form of y equals ax plus b, and you should have done this quite a bit last year. Now this is called the general formula for a linear equation. So this is the general formula for a linear equation. Okay, it's y equals ax plus b. And hopefully last year you learned that a is the gradient or the slope, and that b is the y-intercept. We are going to use this in order to graph these lines. Okay, now gradient and slope can also be written as rise over run. Okay, and this is the way we're normally going to refer to it. Now when you rise, you go up, and when you run, you normally go horizontally, so that means going forward. Okay, so we look at how far the line goes up versus how far the line goes forward. Now, the best way to do this is just to start with an example. So let's do one together. So let's say I have y equals 2x minus 3. Okay, now 2 is our gradient. So our gradient, or is equal to 2. That is our a. A is 2. Okay, now remember we said this is the rise over the run. Okay, now 2 doesn't look like rise over run. Rise over run is a fraction, and 2 doesn't have a fraction as part of it. Okay, but we can write 2 as a fraction by writing it as 2 over 1, or 2 divided by 1, because you know that 2 divided by 1 is still the same thing as 2. Now we also need to look at the b term, which is our y-intercept. Okay, now our y-intercept in this case is the value of b is minus 3, so our y-intercept is going to be 0, minus 3. Okay, this is what we are going to use in order to graph this linear equation. So we will make a graph. Now I'm going to do it quite rough. You guys should be a little more accurate than I am. Actually, I can just move this across slightly, and then it's also accurate. Okay, and we'll move this one down a little bit. Okay. Now, what we always do is we start at that y-intercept. So the y-intercept is our starting point. Now, in this case, it was minus 3. So we go down to minus 3, and you guys should also label your axes correctly. We always put the x and the y on there, and we always put the numbers in. I tend to be a bit lazy and don't do it, but you guys should. Okay, so let's just quickly do this. Now, I do also expect that you try to keep the numbers below the axis. So 1, 2, 3, 4, 5 below, minus 1, minus 2, minus 3, minus 4, minus 5. And on the left, so 1, 2, 3, 4, 5. Because mostly we want to work in this positive space up the top, so we try and keep that one empty. Minus 1, minus 2, minus 3, minus 4. Okay, and I don't ever want to see anybody do a 0 like this. Okay, that's circling the middle, that's not writing a 0. So you should always write your 0 just down here somewhere next to where the 0 will be. Okay, I might just move that one a tiny bit closer. Okay, so we have our axes. Now, our y-intercept is our start point, so minus 3 is going to be our start point, so we could just put a little x at minus 3. Now, we said that our rise was 2 and our run was 1. So what we're going to do is we are going to rise 2 and we are going to run 1. What do I mean by rise 2 and run 1? Well, rise is going up. If I asked you to rise, you would stand up. So from that starting point, you always have to start at the starting point. Go up 2 counts on your axis, and then we're going to run 1. So across 1, then you can put another cross. All right, you actually only need to do it once, but we'll do it a couple of times just to show you how it works. So we're going to rise 2, and we're going to run 1, put another cross. All right, rise 2, run 1, put another cross. And you should see that as we keep doing this, rise 2, run 1, what we're getting is a really nice straight line. Okay, so we can now draw a line through these points, and you guys should use a ruler. Remember, always use a ruler when you're doing any of this stuff, and you'll get a nice line down here through those points. And this is the line of y equals 2x minus 3. Okay, and this is how I would like you guys to be graphing your equations. Okay, let's do another one. We'll just do it on the same axis. So let's do y equals minus a half x plus 4. Let's make it a little easier. Let's make it plus 2. All right, just because we run out of space otherwise. All right, so you should be able to see that your y-intercept is going to be 0, 2. So we know that that start point, and I'll do it in a different color for this one. So our start point is going to be here. Okay, now our gradient is equal to, in this case, minus a half. Okay, and that is our rise over our run. Now you can see here that our rise, in this case, is minus 1. All right, what does that mean? Well, if you have a rise of minus, that means instead of rising, we're going to drop. Okay, so we're going to go down instead of up, and then our run is 2. So if you have a negative, basically, instead of going down, go up. That's the easiest way to remember it. Always, if there's any negative, just make sure instead of rising that you drop. Still run in the same direction. So from this 2, we are going to drop 1. Okay, and then our run was 2. So we're going to go running 2, put a mark. Same spot as the last one. Okay, drop 1, sorry, and run 2, put a mark. Drop 1, run 2, put a mark. Okay, and again, you can see that you get a really nice line. This one's going to be awkward for me, going this way. And again, make sure you use a ruler. Okay, and make sure you then label your line. So y equals minus a half x plus 2. Okay, so that is the main thing that you need to be practicing for 1.2. Okay, there's one other thing, and that is finding out whether a point is on a line or not. Okay, or finding out what the missing variable is. Okay, so let's just use one of our examples here. We had y equals minus a half x plus 2. And let's say we want to know, is 3, 7 on this line? All right, well, we know that here we have an x and a y. So we're going to substitute that in. So instead of y, we're going to write 7 equals minus a half, and then this was our x was 3, so times 3 plus 2. Okay, and then we just need to simplify this and see if it works out. So 7 equals minus a half of 3, so half of 3 is 1.5, so minus 1.5 plus 2. Okay, you can already see it's not going to be correct. 7 is equal to minus 1.5 plus 2 gives us a half. Now, this is not true. So we put a cross through the equal sign. This means is not equal to. That's what that symbol means, okay? And then we must finish this off with a statement. So you always have to write something. Showing these calculations, we definitely need to do that, but you also need to explain your answer. So this means that, therefore, these 3 dots means therefore, if you hadn't already come across it, therefore. Okay, let's say it was point A. Point A is not on the line. And I expect to see you writing something like this properly. I don't want to see no. Okay, if you write no, that's not an answer. Okay, I want to see you write this properly. Okay, now the other thing you might see is that we have a line y equals 2x plus c, and the point b, which is going to be 4, 6, is on this line, and we want to calculate c. All right, I've just written it in shorthand because otherwise it's going to take too much time. Okay, so in this case, we do the same thing. You know you have an x and a y here, so we're going to substitute those in. So the y is 6, so instead of y, we write 6 is equal to 2 times x, which is 4, plus c. And then if we solve this, we will have only c left. So 6 is equal to 2 times 4 is 8, plus c. We minus 8 from both sides. 6 minus 8 is minus 2 is equal to c. Okay, and then remember we always put the variable on the left, so c equals minus 2. Okay, you're going to just see variations of this. All right, it might have that the x is missing or the y is missing and you know the formula, but this is the same technique you should be using for all of these. So substitute your x in and your y in and then solve to find whatever is missing. Okay, it's a lot for one lesson, but you've done all of this in year 2 already, so this is all practice for you anyway. Okay, good luck.